Hi everyone. Today I'll be presenting my field trips finding on in front of you guys. So let's dive into it. General questions. First, what is a drainage basin? A drainage basin is an area of land where all precipitation collects and drains off into a common outlet or a water body. We can use our photocopied portion of our topographic map where you can outline creek's drainage basin by identifying highest elevation and tracing the ridge lines connecting these points. According to the geologic map of Vancouver area, Lynn Creek flows through the sedimentary rocks and sandstone. This information is important as it influences the creek's path and behavior. There are several factors that influences the water flow in the Lynn Creek, which can include the precipitation, snow melt, seasonal changes, and human activities as well. We can expect the highest flows from late fall to early spring due to Vancouver's rainy season, as we all know that, and also due to the snow melt. And also, the flows will be lowest during the summer when the precipitation is minimal. So, from my field trip, I would like to mention about the different processes, geological processes, and findings that I saw and got to experience in my field trip. In the stop one pipeline bridge, downstream from pipeline bridge, Lean Creeks enter a narrow canal, resulting in increased flow velocity. Evidence of flooding in this area uh, can include watermarks on the tree and rocks, debris piles, and eroded banks. The rock material underneath our feet here is primarily bedrock, like sedimentary or metamorphic rock in origin. So, our second stop is creek side clearing. Here, the bed of Lynn Creek contains the rounded boulders and gravel. High flow events such as floods can move this rock material. The rock material where we are standing here may be more weathered or finer in size compared to larger, more rounded in the creek bed. The differences arise due to erosion and transportation by the creek. The clarity of water indicates that Lynn Canyon is not carrying suspended sediments. However, it is during heavy rains or rapid snowmelt. The vegetation in this area of the creek is adapted to the environment, adapted to the flooding, indicating the birds' frequent exposure to the water flow. Larger, more resistant rock type present the downstream end of the bar deposited during lower flow condition. We can also see upper stream of the bedrock. The bank is undergoing erosion due to water flow, which undercuts and destabilize the bank material. And here we can see the erosion and the bank changes. The bank changes and erosion is all due to the differences in the velocity of the water, differences in the speed of water. When the water flows in the higher speed, the erosion is the bank changes occurs because it carries the more the sediments, the particles, where the it reside all those particles in the bank. When we reach our stop 3, we can see a terrace above the 30-foot pool. The flat surface here is a terrace formed when sea level dropped post glaciation, leaving behind a higher flat area as the creek cut downwards. Trees on the terrace are likely older and less tolerant, indicating the more stable environment compared to flood affected area below, which means the trees have well adapted according to the environment. After coming through all the three stops, we are finally at the 30-foot pool, which is really good, which is very beautiful. Upstream of 30-foot pool, Lynn Creek flows through bedrock like sandstone. Uh, at the downstream of 30-foot pool, the creek flows through similar bedrocks with a varying degree of erosion. We can also see the valley shape is influenced by the resistance of rock material to erosion. Harder rocks form steep, narrow valleys, while softer rocks result in wider valleys. The water velocity is higher upstream due to the narrower canal and decreases downstream where the pool forms and canal widens. 30-foot pool formed through the erosion of uh, softer rock layers, creating deep pool. As I've already mentioned, how 30-foot pool was formed. It was formed due to the erosion of softer rock layer, and also the boulders us surrounding us during our field trip and in the bed of Lynn Creek are sourced from upstream erosion and glacial deposits rounded by water transport. The evidences of cliff erosion include exposed roots, fallen rocks, and undercut sections. Much of the eroded rock material has been transported downstream, with larger, more resistant materials are left behind. Last but not the least, when we reached our final destination, final stop, the stop 5 at the middle of the suspension bridge, which seems really nice when we were looking downwards from over there. It was really beautiful. I've also mentioned the sketch that I've drawn from the middle of the suspension bridge. As we can see that uh, comparing the cross section of the stop 2 reveals the difference due to varying erosion resistance of rock types and flow dynamics. The narrow canyon experienced more intense erosion, while the wider valley has slower and more diffuse erosion. The narrow canyon experienced the most change due to higher flow velocities and concentrated erosive forces. The steep, almost vertical canyon walls are due to erosion resistant bedrock, less prone to weathering and collapse. We, hypoth- we hypothesized the variations in rock types, flow rates, and historical geographical event contributing to alternating wide and narrow sections of Lynn Creek. In the conclusion, I would like to mention that from the field trip of my Lynn Canyon, I got to understand various processes. I got various findings that really helped me enhancing my understanding of the geological processes and too many more things as well. So the processes like the velocity of water, how it affects the erosion, the bedrock, the types, and the vegetation around the area, and the flood, the exposed roots indicate the floods, the things like that. It helped me to understand by visiting the real scenario uh, and helping me to understand more clearly and effectively. Thank you so much for your attention.